So when all of you at some point in your lives decide you want to have kids, which I highly recommend because there is a sense of humor you'll get with them, but laugh with them, cry with them, for crying out loud, read to them. And one thing that my daughters had told me, and I didn't realize, they told both my wife and I, we often, when we have dinner in our dining room together. And we have that anywhere from 3 to 5 times a week. And my daughters have said that is one thing that they really enjoy doing, which, you know, it does puts a little bit more on the parent to say, let's make sure we have a meal at the table, but it doesn't matter if you just order pizza. The one thing that we never have at the table, cell phones. And I don't know if you guys are like us, but if our home phone rings, we all look at each other like, what's that? Because who calls other than people to solicit you for, hey, we're going to be in the neighborhood and I don't need to talk to you. Everyone that I know, all my friends, have my cell phone number. All my wife's friends have her cell phone number. All my daughters have, their friends have their cell phones. Like, let's face it, just like you, they communicate via Snapchat and Instagram and what other is the fancy thing, right? I think it makes you kind of normal. But so if I don't believe in helping you, I apologize. Sorry, I haven't conveyed that clear enough that you're always welcome to come get help. So I just want to make sure I put that out there. All right, so we're going to start working with these. So let's start out just factoring. Okay, and I'll give you a warm up on factoring. Let's make sure we remember this. Did I give everyone notes? Okay, just make sure. So let's double check to see if we can factor. So remember our initial way is we multiply those together and we get negative 20. And then we know we have a positive and negative, and we have to think of the factors of 20. So I'm just, for sake of time, going to say we're going to use 4 and 5. And I know I have a positive 5 and a negative 4. If I multiply those together, I get negative 20. If I add those together, I get the positive 1, which is right here. Right? And I get the hiccups again. Excuse me. So I get x squared minus 4x plus 5x minus 20. And then remember we underline those and say, okay, I have x and x minus 4. And I underline those, and I have positive, and it looks like a 5, and x minus 4. And then that gives me an answer of x minus 4 and x plus 5. One day I'll give myself actual room on these to write down. Remember that? And we're not setting them equal to 0 because we're missing a key thing up there. We don't have an equal sign. So we're just breaking them down. So we do the same thing to problem number 2, same idea. Again, we're going to multiply the first and the last, so I get negative 16. And we have to think about the factors. I know one will be positive, one will be negative, but 8 and 2 would work for us, where I'd have a negative 8 and a positive 2. If I add negative 8 and positive 2, I get the negative 6. If I multiply, I get the negative 16. So I get x squared minus 8x plus 2x minus 16. And then I get x and x minus 8, right? And on this one, it looks like I can factor out 2, x and minus 8. And then that factors down just to x minus 8 and x plus 2. You remember this? We did this about a month ago, I guess, maybe? Before spring break, definitely before that, right? And then when you get to like problem number 3, we're still doing the same thing, but we're going to go negative 18 times what? 2, right? So let's bring this down a little bit. All right, so I'll multiply those together. That gives me negative 36. So I have positive and negative, and the factors of 36, that would add up to 9, would be 12 and 3, I think. Is that right? It would be a negative 12 and a positive 3, because when I add those together, I get the negative 9. If I flipped it over, I'd have positive 9. And then I'm going to go 2x squared minus 12x plus 3x minus 18. We're going to factor out here. And we're going to factor out a 3. And then my overall answer is x minus 6 and 2x plus 3. Hey, Hey, question, could I have 2x plus 3 and x minus 6 as well? Yeah, I can take them and change the order. And then the last one, my magical number is going to be, what is that, -6? And so I have one positive, one negative, I have a positive 3, and I have a -2. And that would add up to be the positive 1, right? Because there's always a 1 in front of the variable. We just don't put it. So I got x squared, 6x squared plus 3x, minus 2x minus 1. And look here, I have a 3x, and that's 2x plus 1. That negative sign has to come down. So I'm just factoring a negative out of both those, so I get 2x plus 1. Because I factored the negative, that's why both those signs changed. So 2x plus 1. And that was a -1 right there, so 3x minus 1. Remember that? We've seen that before, right? I'm just trying to get the cobwebs out. Reach back into our memory a little bit. Okay? Can I move on? Christian, you good?
Yeah.
Okay. All right, so what's the difference between a linear function and a quadratic function? Well, the graph of a line is a straight object that goes from left to right, or from top to bottom, or diagonal up and to diagonal down. A quadratic forms a parabola. So it either opens up or it opens down. Yes, there are parabolas that open to the right, to the left, but you don't see that until you get until the end of the school year for Algebra 2 and pre-calculus, or college algebra, you might see it. Okay, so a linear equation just looks like anything like this. If I graphed it, and then a quadratic, ooh, we're gonna be cool. Will look like that. And look at how fancy that is, huh? So those are the only two types of quadratics we will deal with. And we know that we have a maximum and minimum value. We have a vertex. We have an axis of symmetry. We have all those kind of things, right? So how do we solve linear versus quadratic? Well, the linear equation, and this might take you back. Remember we did the dotted line? Remember that? And then we add 12 to both sides. And that dotted line represents that we have an equal sign. So 14 added to 12, I believe, is 26. Divide each side by 2. So we find that x equals 13. And so that's a solution. That's a solution. And then if we were to solve the quadratic formula, we could try and factor it. Okay, so if we factor it, I know I'm going to multiply my last times my first, so I'm going to get that -20. So I know I have positive and negative, because to get a negative number, that's what you'd have to do. And I'd get a +4 and a -5, because if I add +4 and -5 together, I get to the -1, right? And this is now going to give me, oops, I didn't want to go quite that like that yet, sorry. That's going to give me x squared plus 4x minus 5x minus 20. Look what I have in common here. I have an x, so I have an x plus 4. And I have a -5 that I can factor out here, so that gives me x plus 4. Remember, the signs change when I factor a negative out. And then I wind up with x plus 4 and x minus 5. But we're solving it, so what should we do with each of these now? What should I do with each of them?
Set them equal to 0.
Yeah, set each little thing equal to 0. So I get x plus 4 equals 0. So that gives me x equals -4. And x plus 5 equals 0. So subtract. So I get, oh, that's -5, right? Sorry about that. So I add 5 to both sides, so I get a +5. So I have two answers here, and I have one answer with linear. And the answer, all it really means when you have the answer is, where does it cross the x-axis? And we know that some linear equations don't cross the x-axis. We could have a line that's parallel to the x-axis and it won't intercept it. And that's always the equation, y equals some number. So you can't solve for x with that because you don't have an x available. And we also know that some parabolas don't cross the x-axis because they either open upwards and the vertex is above the x-axis, or they open downwards and the vertex is below the x-axis. So there are some situations that it doesn't solve to be what is called a real number, but Sometimes it might be a real number that happens to be irrational, and then it might be a real number that is, or a not real number, which is called a complex number, and sometimes we refer to it as an imaginary number. And that's when you have a square root sign and you have a negative under your square root sign. I think there's a couple problems below too, aren't there? Okay. How would we do this one down here? What do you think? Oh, perfect. Distribute that 3 here and here. So that's going to be 6x minus 12 plus 8 equals 5x minus 9. Combine like terms. We could subtract 5x. And then metaphorically, we have this dotted line. So that's going to give me x minus 4, or that's 1x minus 4 as well, equals negative 9, add 4, and so we find that x equals negative 5, so that's our solution, and that's where it crosses the x-axis. Did you get it all done?
Yep.
Okay. Let me check it real quick.
Oh, come on.
Oh, come on, we got it written down. Let's froze. All right. Spell your last name.
B-O-S-M-A-N.
Clarice. Log, log, log. Aw, you only got a 90% this time.
Woo!
Nice job.
Hey, I didn't ditch the last math test. I got a 97.
I'm so proud of you.
Oh, never did.
So, something that is coming your way, which you might have heard of and you might not have heard of, but there are 3 capstones that exist, and that so it's starting with the sophomore class right now. There are 9 different math capstones, and you only have to pass one of them. But one of the capstones is Algebra 2. And Algebra 2 would be a class you would take after you would take geometry next year. And once you, on the capstone, there's one that's on logarithms, there's one on polynomials, which is similar to what we're doing, and then there's one on irrational function, or rational functions, excuse me. But you have to get a 7 out of 10 on any one of these tests. And so we are fine-tuning it, and I think by the time you guys have to take it, I think we'll have it cleaned up a little bit. But I wanted to just show you this. I go to here. So right now, as far as, so you can see these are all the different tests that we have available for us. So right now we have 1,267 students that have passed all of their capstones that they've taken, one of the 3 tests that there are on math. Now here's the scary part. There's 616 students that haven't. But we're really working on how we can make this work. And again, you have a whole bunch of other capstones that you can take to satisfy it. But we'll make it work. Of that 616 that didn't, there are juniors and seniors that know they don't have to worry about it right now, because it's not their class that's affected. It's the freshman and sophomore this year, and the 8th graders and 7th graders coming up. But hopefully we'll get that to be a nice number. And if you don't pass that capstone, then you have the ACT, the SAT, the ASVAB, which is a military test. You have to score a 2 or better on an AP math exam. And so these are just some of the other capstones. And there's one that's like if you got a industry certificate that had a math content to it. So like if you were to go to the new CTE school, and let's say you were to do the construction careers class, there is a geometry of construction careers class that you would take, and that you get a certificate, and that would also satisfy the capstone. Not that you're going to go into construction, I'm just trying to give you a thing. So there's a lot of different ways to show that there's success, and I'm on the committee for the Algebra 2. And I can tell that here at this school we're doing quite well in comparison to the rest of the district. When I look at our donut of how well we're doing versus how well we're not doing, I think, oh no. And then I go see the district meeting, and the district as a whole is opposite of what our donut looks like. They have like more kids who haven't passed it than have passed it. And it's like, oh, we're doing pretty good. But we got to make sure I can get the 616 or however many kids I said that was to pass. Problem number 4, ideas on how we might want to solve it.
Subtract 6x from x squared.
Okay, I can't do those together because one's x squared and one's x, so I can't do that.
Would you add the 6 to the 16?
I like your thinking, so we're definitely going to have to move something back across, but let's go the opposite way of what you just said.
Subtract.
It's the 16.
Oh, okay.
So if I bring the 16 over on this side, I'm going to get this. Get to that. And then I'm just, for sake of time, I'm going to say this is what it factors to. Just because I've seen it a few times. If you're like looking at it going, dude, how'd you do that? Teach for 24 years and you'll see the same patterns over and over again. And I would strongly encourage you to be math teachers. I love what I do. I don't work. Even when I get yelled at, I don't work. So then I said each of these equal to 0. There you go. So 2 answers when it's squared, 1 answer when it's not. How are we doing? Let's see how much more I got. This is the last slide right here? Yay! Okay. Talk me through it. Give me direction.
Positive 12. We'll just do positive 12.
Okay, so you want to move to positive 12 over. I like that. What else? So this is now moved over.
Says 8x minus 2x.
8x, are they both positive or negative? So positive. And then? Divide by?
Divide by 10.
Yeah, so you get 2. And I guess I should go down, but I'm just going across. Okay, number 7 is raised to the 3rd power. So how many solutions could we have? 3, yeah. So first thing I'm going to do here is I have to say, you know what? I can, of all 3 of these, I can take an x out, and that leaves me x squared minus 8x plus 12, and set that equal to 0. Okay? Remember this first x here, so that's going to give me one of my answers is x equals 0. That's one of my answers. So now I have 2 more answers to find. So I'm going to break this down to x minus 6, x minus 2. And again, I'm just factoring them quickly. So that gives me x minus 6 equals 0, so x equals 6. There's a second 0, and x minus 2 equals 0, and x equals 2. So my answers, if I had graphed this graph actually looks like this. And it crosses the x-axis 3 different times. So one of the times would be at 0, one would be at 2, one would be at 6. But you don't have to know how to graph those as of yet. I'm just showing you what they look like. What about that bottom problem down there? Does it factor like that, or is it the difference of 2 squares? If it is the difference of 2 squares, how would that factor?
6.
3x plus 6 and? What's the other one?
3x.
Yeah, 3x minus 6. And again, those are both be set equal to 0, so I get 3x plus 6 equals 0, and I get 3x minus 6 equals 0. So I'm going to subtract 6 on this one, so I get negative 6 over here, and divide by 3, so I get negative 2. And on this one, I'm going to add 6 to both sides, divide by 3, so I get my 2 answers there is 2 and negative 2. And then number 8 is the simplest, most hard problem you ever see. I don't have a different number. Any ideas how you should go about it?
Add 9.
Well, you'd have to add an x with it. I'm not sure if that'll help us. I like your thinking, though. What do I have in common between those two? X and a 3, right? X and a 3, 3x? So if I factor a 3x out, I get x here minus 3 equals 0. What does this have a result of an answer of? 0. Right? So there's one answer, and then this is x minus 3 equals 0, so I get x equals 3. That's it. That's all we know how to do. Okay, so let's see, where are we at in our review? We did that. Yeah. So what did we say? We do page 115, 116. Oliver, odd or even, your choice. Odd, okay. So page 115, 116, the odd ones. And Oliver dictated what you all have to do, and he dictated what 6th period has to do as well. Sound good? And we even ended with 8 minutes to spare. Dude, that's not a bad gig. Hey, is everyone okay? Everyone make to the assembly, I hope?
Yeah.